So, and the next and a very important piece here that Rob mentions is basically that the PD view, the bioenergetic view, ignores the ancestral model and evolutionary biology. I'll let you, I guess, share the quote real quick.
Sure. So this is Rob's quote. He says, "But I think that they end up purposely just ignoring evolutionary biology, which is kind of like, how the F do you do that? How does any credible person discuss health at all and not have some steeping in the evolutionary biology of this stuff?"
Yeah, that one. So in short, I would say that the bioenergetic view does not at all ignore evolution. I think the biggest thing here is to just not marketing it as ancestral eating or something, because I think it's a piece of the picture, but by no means the only thing to consider. And that's because of some variance in the view on evolution, both in terms of the actual process of evolution and also the lineage of humans and what exactly that means for what we should be eating. And so I think the couple of things that are kind of being suggested here is that a lot of people are saying, from the low carb view, say things like, we naturally would not have had food available all the time, so fasting is evolutionarily consistent. It's what we would have been doing. Same thing with carbohydrates. We didn't have carbohydrates available all the time, so it's normal. It's again, evolutionarily consistent. It's what we would have been doing to avoid carbohydrates or not having them, and in whatever capacity. And there are a handful of issues here that I guess we'll kind of break down one by one. The first, and you kind of alluded to this earlier, is just this different perspective on evolution, what is optimal versus what we might have adapted to. And when you're coming from the neo-Darwinistic genetic determinism model, what you basically are left with is that whatever we are genetically determined and adapted toward is ideal. So, and any variation from that is not ideal, that is worse. And that's because we randomly got to wherever we are now genetically, and we had an environment that was compatible with that. And so because of that, we're stuck with whatever was kind of evolutionarily determined through this genetic determinism model. And if that didn't involve a lot of carbohydrates or it involved a lot of fasting, that's what we have to stick with, because that's what our optimal health was built around. As opposed to a view that involves a two-way street between the environment and genetics and heredity and evolution, where the availability of things in the environment, the changes in the environment, the energetic availability of the environment has a directing input in terms of what's going on genetically and hereditarily and evolutionarily. Where if we were in an environment that could have supported greater brain function, and for long enough, it would allow for greater brain function over time, greater complexity, and that will lead to shifts in terms of epigenetics and genetics and on from there, and actually shifts in terms of speciation and evolution. And we've talked about doing a series on these different views of evolution before, and we certainly will, but it's way too much to kind of dig into now, but just kind of sharing here, there's not an ignorance of evolution, it's rather just some differences in perspective here. And to be at least a little bit more specific and provide an example or two and some evidence to support it, basically the idea that we're suggesting in terms of carbohydrates is that having an energy-rich environment that allows for us to produce a lot of energy that involves carbohydrates is something that was key in the development of where we are now and having large brains and all of that, but also is something that allows us to further complexify and improve along those lines. Even if, let's say, for all of the development, and this likely was not true, but let's say for all of development, we only had 100 grams of carbohydrates available per day from fruit. Now, if we have 200 grams available, that doesn't make that worse. It actually could mean that could allow us to continue to improve in terms of complexity and function. In terms of some more specifics, I do think it's also worth considering that when looking back at our lineage and our development and evolution, it likely was in an environment that was largely carbohydrate rich. Of course, we don't know exactly what things were going on, but based on the evidence now, I think that can largely be argued, and there's a few reasons for that. The first couple that I'll say, there's an article by Denise Minger, and it dispels the idea that any fruit that was available in the past was very, very low in sugar and carbohydrates, and discusses the fact that the wild fruits that would have been available actually were very dense in sugar. And so they actually would have provided a considerable carbohydrate source. Another piece that's not often talked about is honey. But when you look at modern day hunter-gatherers, honey is a huge source of carbohydrates. There's a study, I'm not going to read the direct quote, but they look at, I'll cite it, they look at all current hunter-gatherers in warm climates, and all of them except for one consume honey. The one that doesn't consume honey is because they're in the Philippines and they spend most of their time on boats, so they can't really collect honey from the boats. But anyone else, like any other cultures that have honey available, use honey as well as a major carbohydrate source. So those are two of the main sources that would have been available in terms of carbohydrates. And when we consider that the vast majority of our evolutionary heritage occurred in tropical warm climates, we would have had those things available, ideally, most likely year round. And that, when we consider the millions and millions of years of evolution through apes, so just for reference, the kind of the class, what is it? I don't know if it's genus. It's probably genus that we're in, which was humans and like other bipedal organisms, separated from chimpanzees between 4 and 7 million years ago, according to the typical data now. So that's a really long time of development for us to have in these warm climates where there's likely carbohydrates available. And even with all that in mind, if we consider when there was actually the emergence of modern day humans, which was estimated, 300,000, 400,000 years ago, we really didn't leave any tropical warm areas until around 30,000 years ago, is basically current estimates. So for the vast majority of our biological evolution, it was likely occurring in environments that were very carbohydrate rich. So these are, again, there's more to discuss here, but just kind of putting these out as small talking points for how this view can still incorporate, how the bioenergetic view still incorporates an evolutionary perspective. And the last point I'll make here is that there's also some good evidence that this is what is allowed for the development of our brains. And this is looking at things like the expensive tissue hypothesis and looking at apes as well. And so when you look at apes, which of course were part of that family, there is a strong correlation between fruit consumption and brain size, where normally the apes that are consuming much more leaves and stems and indigestible carbohydrates and relying on much more fermentation, they have smaller brain sizes compared to the ones that have a lot more fruit coming in. And this is basically, you can predict the intelligence and brain size based on the diet in these terms. So that's an important piece to consider here. And then we have the expensive tissue hypothesis. And then I'll let you go, Mike. I know I'm kind of trying to speed through these last points here. But so I'm going to share a couple of quick quotes here describing the expensive tissue hypothesis in some clear terms. And so this is from a study titled The Expensive Tissue Hypothesis, the Brain and the Digestive System in Human and Primate Evolution. And they state that the expensive tissue hypothesis suggests that the metabolic requirements of relatively large brains are offset by a corresponding reduction of the gut. The splanchnic organs, the liver, and GI tract are as metabolically expensive as brains, and the gut is the only one of the metabolically expensive organs in the human body that is markedly small in relation to body size. Gut size is highly correlated with diet, and relatively small guts are compatible only with high-quality, easy-to-digest food. The often cited relationship between diet and relative brain size is more properly viewed as a relationship between relative brain size and relative gut size, the latter being determined by dietary quality. So what they're saying here is that when we have a high-quality, easily digestible diet, that allows us to expend more energy on having a really great, complex, energy, expensive brain and wasting much less energy on our guts. And this is something that might be normally acknowledged by the low-carb crowd because a lot of times animal foods and meat are pointed to here, but this also includes fruit as a really easily digestible carbohydrate source, or honey as well, that don't require fermentation in large intestines or anything like that. And so the last quotes here I'll state are from a separate study. And this study is titled Effects of Brain Evolution on Human Nutrition and Metabolism. And they state, that same thing where the relative size and morphology of the human GI tract also reflects our high-quality diet. Most large-bodied primates have expanded large intestines in adaptation to fibrous low-quality diets. Humans, on the other hand, have small gut volumes for our size, with relatively enlarged intestines, small intestines, and a smaller colon. And then they state that the large metabolically expensive human brain is partially offset by the consumption of an energy-dense and nutrient-rich diet. This relationship implies that the evolution of larger hominin brains would have necessitated the adoption of a sufficiently high-quality diet, including meat and energy-rich fruits, to support the increased metabolic demands of greater encephalization. And so this is what we're getting at here, the evolutionary perspective here that is directly entwined with the bioenergetic view.
Yeah, I mean, you basically covered all of the points, and we've covered these in other episodes as well, so I don't have too much to add there. The only thing I would just say is that the vast majority of the ancestral communities, diets, whatnot, hunter-gatherers that we're seeing are not just like in ketosis. And I think that's a really huge point to point out as well. It's not like, the Hads aren't walking around in ketosis all the time. The Kitavans aren't walking around in ketosis. The populations that Weston A. Price study weren't walking around in ketosis. Now, not all of them were hunter-gatherers, but the ancestral communities, like there's a few that were functioning in ketosis to a large extent, and that was most likely the extreme northern populations, the Eskimos. But even then, there was question as to how long they were actually in ketosis, the degree of the ketosis that they had, and then they also have specific metabolic adaptations as well.
Well, and that was recent, right? That was within the last 30,000 years of our evolution. So I think to argue that that is ideal just from the evolutionary stance is questionable.
Yeah.
And as you're saying, it's very uncommon, and they had costly adaptations to be able to do that. Also, even if they were doing that, that doesn't mean it's optimal or ideal. Kind of as you were saying also, like we can look at the Hadza, but just because they're subsisting in whatever environment they have with their current food available doesn't mean that that is an ideal diet for the human species.
Yeah, and my point being is that, like, you talk about, there's this idea, we need to be evolutionarily consistent, but it's like ketosis, like being in ketosis on a regular basis doesn't seem to be evolutionarily consistent. Like, I'm not seeing the argument for that at all from previous cultures, whatnot, etc. What you're seeing is most cultures have carbohydrate content. There's a wide range of carbohydrate consumption and still having a degree of health and health span within these different populations. And a lot of them aren't really approaching ketosis. And the ones that are, there's dispute about whether they were. I mean, the Maasai weren't really in ketosis. That's something that's been discussed and talked about. And so, yeah, and Rob did have an offhand comment to those things after he said that, to be fair, inside the mm-hmm. transcript. But the other thing that I want to just briefly touch on, because I know we're wrapping up here, but the physiologic mechanisms that we are discussing here and going over are direct representation of our evolutionary history. It's the body trying to basically create systems to deal with the environment that we are functioning in. And if you want a direct insight into what went on evolutionarily, et cetera, over a period of time, you start to see these changes in these adaptive hormones, whatnot, and things centering around energy production. Then you start, like, from all angles of this evolutionary consistent approach, you're seeing it not to rely on ketosis and low carbohydrate diets, etc. There's multiple mechanisms to go into there, and we discussed some of them earlier today. There's quite a bit more, but it's not that we throw out the evolutionary consistent perspective, at least from our end, because we came from that to some extent. We're just not seeing that the evolutionary consistent perspective is one that's ketosis, and then just
or low carb,
or low carb, or necessarily low carb, and then he did mention Paul Saladino, but Paul Saladino is not doing ketosis or low carb, but he's evolutionarily consistent, and he's not bullshit.
Yeah, just real quick before, because I do want to just have we'll comment on that, but I wanted to mention also, again, our closest relatives that are extant are the bonobos, and we talked about this in the recent episode talking about fructose and uric acid. But their diet is at 60% fruit pretty much year round, with huge amounts of sugar and fructose. And that is fueling their brains. And you see that again, that throughout all apes, the ones that are most intelligent are having the most carbs. And so you'd have to suggest that we have quite a divergence if you want to suggest that we should be eating low carb. And, interestingly, when you look in the animal kingdom, you don't really see the carnivores being the ones with the big brains.